Welcome back everyone. This video covers the AMDM recursion quiz review. In the first 4 questions it says identify the following scatter plots as having a strong positive, strong negative, weak positive, weak negative, or no association, and justify your answer. For graph number 1, we can see that as the x values are increasing, the y values are also increasing. In other words, as you move from left to right, we can see that the points are trending upward. That gives us a positive association. Also, the points are very close to a straight line, and therefore it is a strong positive association. So for number 1, the answer is strong positive association. Let's take a look at graph number 2. We can see that as the ages are increasing along the horizontal axis, the testosterone levels are decreasing along the vertical axis. In other words, as you move from left to right, the dots appear to be in a downward trend. The downward trend indicates that we have a negative association. Also, the points appear to be pretty scattered, and they are not really close to forming a straight line. Therefore, the association is weak. Putting this all together, we have a weak negative association. All right, for graph number 3, we see the points are very scattered. As you move from left to right along the horizontal axis, the y values are not really trending upward nor downward. Therefore, we say there is no association. So number 3, no association. For graph number 4, as the values along the x-axis are increasing, the values along the y-axis are also increasing. As you move from left to right, the graph tends to be trending upward. So there is a positive association. And I would say that the points are fairly close to this line, and therefore I would say a strong positive association. Okay, for problems 5 through 7, it says identify the following sequence of numbers as modeling a linear function or an exponential function. Explain your answer. Now, as a reminder, if we have a linear function, then you're adding by the same number every time, and we call that a common difference, which is d. If it's an exponential function, then you're multiplying by the same number, and we call that the common ratio, r. All right, so for number 5, we need to determine if it's linear or exponential. So if it's linear, you're adding the same amount. If it's exponential, you're multiplying by the same amount. So let's figure out what's going on here between each number. First, let's explore the linear option. So you would take the second number of 25 minus the first number of 100. 25 minus 100 is negative 75. Then take the third number minus the second number. 6.25 minus 2.5, or I'm sorry, minus 25 is 18.75. Well, we can stop right there because we can see that these two differences are not the same. They're not common. Therefore, we know it is not linear. Now let's explore multiplication. So to see if we're multiplying by the same amount, you take the second number of 25 and divide it by the first number of 100, and you get 0.25 or 1/4 as a fraction. Now take the third number and divide it by the second number. 6.25 divided by 25 is 0.25, which is 1/4 as a fraction. So this seems to be consistent. And likewise, if we divided the fourth number by this third number, we would also get 0.25 or 1/4. Therefore, we do have a common ratio of 1/4. That's what we're multiplying by every time, and therefore this is exponential. All right, let's see what's happening with number 6. Well, it's easy to see that if you start with 5 and add 3, you get 8. And if you add 3 again, you get 11. And 11 plus 3 is 14. Therefore, this is linear because we have a common difference. All right, for number 7, we go from 1 to 5 to 25 to 125. And I think it's easy to see what's happening here. 1 times 5 is 5. 5 times 5 is 25, and 25 times 5 is 125. So we have a common ratio, r is 5, and therefore this is exponential. All right, it says for each of the following problems 8 and 9, find the following. Graph or sketch the scatter plot, identify the data as linear, exponential, or neither, write the recursive rule, write the function rule, also called the explicit rule, and answer the question. So for 8, the following table shows the population for a newly discovered species of bacteria in a petri dish after 5 hours. What is the expected population for the bacteria after 8 hours? All right, first let's show the scatter plot. On the horizontal axis we have the hours, and on the vertical axis is the population, and this first point is the ordered pair 0, 115.11. And this is the second point, 1, 143.89, third, fourth, fifth, and 6 points. All right, so that's your scatter plot. Next, we want to figure out what's happening in between each number. Are we adding the same amount, or are we multiplying the same amount, or neither? First, let's explore adding the same amount. So we're going to see if there's a common difference. So take the second number and subtract the first number from it. So 143.89 minus 115.11 gives us 28.78. Now take the third number minus the second number. So 179.87 minus 143.89 gives us 35.98. And we can see that these two numbers are not the same. So we do not have a common difference, and therefore it is not linear. Now let's see if it's exponential. If it's exponential, then you're multiplying by the same amount. So to find the common ratio, we would take the second number and divide it by the first number. So that's 143.89 divided by 115.11, and we get approximately 1.25. Take the third number divided by the second number to see if we have a consistent common ratio. So 179.87 divided by 143.89 is 1.25. That's the same as the first ratio. And if we continue all the way down, we would get the same ratio. So we have a common ratio, and that is 1.25, and that means it is exponential. So you're multiplying by 1.25 every time. Now we want to write the recursive rule. The recursive rule is a sub n plus 1 equals a sub n times your common ratio of 1.25. We state that a0 is 115.11, and that n goes from 0 to 1 to 2, etc. Next, we'll do the explicit function rule, and that's a sub n equals the first term, a0, which is 115.11, multiplied by the common ratio of 1.25 raised to the power of n. And then include that n is 0, 1, 2, etc. Now we want to answer the question, and that is, what is the population after 8 hours? So you take the explicit formula and just plug in 8 for n. So that's 115.11 times 1.25, all raised to the power of 8. That just goes in your calculator, and you get approximately 686.11. Number 9 says the following table shows the U.S. population from 1990 to 1995. In what year did the U.S. population exceed 300 million residents? All right, first we simply plot the scatter plot here, and we go from 0 to 5 on the horizontal axis, and that is because 1990 represents the year 0, 1991 is year 1, 1992 is year 2, and so on. So we're starting at 1990, year 0. All right, so this is the scatter plot for the points that you see in the table. Now we want to figure out what we are doing in between each number. Are we adding or are we multiplying? And as you can see, it ends up being that we're adding by 2.8 every time. The way you figure that out again is take the second number minus the first number. So 252.2 minus 249.4 gives you 2.8. Take the third number minus the second number. That's 255 minus 252.2, and you also get 2.8. So you can see that is consistent. Therefore, we do have a common difference of 2.8, and it is the same all the way down. So common difference is 2.8, therefore it is linear. Now we write the recursive formula. That's a sub n plus 1 equals a sub n plus the number that you're adding every time, 2.8. State that a0 is 249.4 and that n is 0, 1, 2, etc. For the explicit function rule, it's a sub n equals the number you start with, that's a0, plus the common difference multiplied by n. So that's 249.4 plus 2.8 times n. And n is 0, 1, 2, etc. And then finally, we answer the question. The question is, what is the year the population will exceed 300 million? So we take our explicit formula and set it equal to 300 million. Then you'll use algebra to get n by itself. So subtract 249.4 from 300. That gives you 50.6. And then divide 50.6 by the 2.8, and you get approximately 18 years. Now that's 18 years later, or 18 years beyond our beginning year of 1990. So take 1990 and add 18 years to it, and you get the year 2008. All right, for number 10, it says a bank account is opened with a $600 deposit. After the first year, no extra money has been deposited and the balance is $610.25. Write the function rule, recursive rule, and find the account balance after 15 years. So first, bank accounts grow by a certain percent or a certain common ratio. So to find the common ratio, we take the balance after the first year and divide it by the initial balance. So 610.25 divided by 600 gives us a common ratio of R equals 1.01708. Now we can write the recursive rule. It's a sub n plus 1 equals a sub n times the common ratio R. That's 1.01708. State that a0, the amount we start with, is 600, and n equals 0, 1, 2, etc. For the explicit function rule, it's a sub n is equal to the amount you start with of 600 times the common ratio, 1.01708, raised to the power of n. And again, n is 0, 1, 2, etc. And then answering the question, find the balance after 15 years. So that's a15 equals the explicit rule and plugging in 15 for n. So that's 600 times 1.01708 raised to the power of 15. Put that in your calculator and you get 773. So $773.53. All right, for number 11, it says a phone company charges a $10 monthly fee and then 2 cents for every minute used. Write the function rule, the recursive rule, and determine how many minutes must be used in order for the monthly bill to exceed $50. First, we recognize that 2 cents is added every minute. So we have a common difference of 2 cents, and therefore this is linear. The recursive rule for linear is a sub n plus 1 equals a sub n plus the number you're adding every time, which is 0.02 or 2 cents. We begin with A0 being $10 and N is 0, 1, 2, etc. For the explicit function rule, A sub n is equal to the number we start with, $10, plus the 2 cents for every minute, and then times n minutes. So 10 plus 2 cents times n. And of course n is 0, 1, 2, etc. And then finally we answer the question, which is how many minutes has gone by when the bill exceeds $50? So we start with the explicit formula, 10 plus 0.02 times n, set it equal to 50. Subtract 10 from the 50 to get 40, and then divide the 40 by 0.02, and that's going to give you 2,000. So it's going to take 2,000 minutes before the bill will exceed $50. And this concludes the video for the Unit 4 Recursion Quiz Review.